Okay, this lesson is on modeling with equations and linear modeling. And I've written some guidelines for modeling with equations, and I'm going to go through this as I do examples, but you should pause the video and just make sure you read through this. Okay, so the first example says, a car rental company charges $30 a day and 15 cents a mile for renting a car. A tourist rents a car for 2 days and the bill comes to $108. How many miles was the car driven? Okay, so before we can answer the questions, we have to set up the variables and a relationship between the variables. So the best place to look is the question, right? So how many miles was the car driven? So we want to know how many miles. So let's let M equal the number of miles. Okay, so the question will give us the variable, which means that's going to be your input. That's your X. So every model, every function has a relationship between two things, an input and output. So let's reread the problem and see if we can find what the output is. It says a car rental company charges $30 a day and 15 cents a mile, which is M, for renting a car. A tourist rents a car for 2 days and the bill comes to $108. So we can see that the number of miles that you drive is going to determine your cost. So if you know the number of miles, you'll know the cost. So C of M is the dependent variable, and that's the cost in dollars. Okay, this is called the Math English Dictionary. You always want to try to do that for every word problem because it kind of helps slow you down, and now it's like an if-then. If you know the miles, you know the cost. So then you reread the problem again, and you try to write a relationship between miles and cost using your given information so that you can find out this answer. So I'm going to read it again. A car rental company charges $30 a day. Well, day's not in here. Okay, so that's the fixed cost, right? So he's rented it for 2 days, so he's got to pay $30 for 1 day and $30 for another day. So the cost is made up of the $60 he pays per day for the 2 days, plus 15 cents a mile is the same thing as saying 15 cents per mile. And we know M is miles. So if he drives 1 mile, it's 15 cents. 2 miles, it's 30 cents. 3 miles, it's 45 cents. So this is a variable. This is a variable amount. This is a fixed amount. This is a variable amount. And so cost is in dollars, so we need to make sure we say 15 cents is 0.15 times M. Okay, so there is our equation. It's a linear equation. That's the slope. That's the rise over run. You go up 0.15, you go for every mile over right one. So that's the variable and that's the fixed cost. And now that we have an equation that relates miles and cost, we can answer the question. The bill comes to $108, so the cost is $108, and we can solve for M. So we're going to subtract 60, which is 108 minus 60 is 48, equals 0.15 M, and we're going to divide by 0.15. And so M equals 320, and then you always want to answer with the units. So M is miles, so 320 miles is what he drove or she drove. All right, you just have to do these, and the more you practice, the better you get. Okay, the second one says a rectangular building lot is 8 feet longer than it is wide, and it has an area of 2,900 square feet. Find the dimensions of the lot. Okay, so this is a different situation. So right here where it says organize the information, the first one, I didn't draw a picture. I was just trying to relate the two things, miles and cost. But this one would be a good idea to draw a diagram because we've got a rectangular building lot and we know a formula that we can use. All right, but before we do that, we need to label the picture. So you draw the picture, you label picture. It says a rectangular building lot is 8 feet longer than it is wide. All right, so we don't know how wide it is, but we know that it's 8 feet longer than it's wide. So with this, what I'm going to do is I'm going to let W know the thing I know least about, which is the width. All right, and we have to think about the units. So I'm going to keep reading. It says an area of 2,900 square feet. So this width must be in feet. All right, so I'm going to label this picture, and I'm going to let this be the width. And then I can label the length because it says it's 8 feet longer than it is wide. So this would be W plus 8. All right, now what do we do with this? Well, we're given the area is 2,900 square feet. Why would they give that to us? That's always something that you should think about. Well, sometimes we can write the relationship because we know of a formula, right? So we're going to use a formula that we know, like the area of the rectangle. We know area of a rectangle is length times width. And we were told the area was 2,900 feet squared. And so we know the length is W plus 8, and we know the width is W. So W times W plus 8. So now we have an equation that's going to, if we solve it, we'll be able to find the width. And if we find the width, we can find the length. So that's what this means. Find the dimensions of the lot. Dimensions means to find the length and the width. Okay, so we have to remember how to solve that. And you can see from past lessons, W times W, that's W squared. So this is quadratic. So you have to set it equal to 0. So I'm going to go ahead and distribute the W and then move that 2,900 over. All right, now we could try to factor that, but 2,900 is a big number, so we could just use the quadratic formula and see what happens. So W equals -8 plus or minus the square root of 8 squared, which is 64, minus 4 times 1 times -2,900, all over 2. All right, so I got -W plus or minus the square root of 11,664 over 2. Now, since this is a word problem, I'm going to be okay with decimals. If it's not a word problem, I wouldn't want to leave it exact. So I'm just going to figure out what both of these are. So I'm going to use this horizontal, and I'm going to just type the whole thing. -8 plus the square root of 11,664 over 2 gives me exactly 50. But there might be another answer, 50 somethings. And then I'm going to put in -8 minus the square root of 11,664 over 2. And I get -58. Now, let's talk about that. So W is in feet, right? So with these, your quadratic doesn't know it's coming from a word problem, so you have to throw this out because it can't be negative feet. So we know the width is 50 feet. Well, it says find all the dimensions. So when I draw a picture, I like to go in and solve the mystery. We now know that the width is 50 feet, and the length would be 58 feet. All right, so we have width is 58 feet, and length is 58 feet. All right, let's try another one. Now, this one is going to be a tough picture to draw. The square garden has a walkway 3 feet wide around and its outer edge. If the area of the entire garden, including the walkway, is 18,000 square feet, what are the dimensions of the planted area? So we're looking for length and width. That's what dimensions mean. And you can't panic. All right, this one's going to be tough. But you're not supposed to know how to do it right away. Let's get that out of the way. But we can draw a picture. First of all, it's a square garden. So all 4 sides are equal. Okay. Second of all, the garden has a walkway 3 feet around its outer edge. Okay, so I'm going to label this. This is 3 feet. This is 3 feet. This is 3 feet. And this is 3 feet. And this is 3 feet. This is 3 feet. And this is 3 feet. And that's 3 feet. How did I know to do that? Well, because I saw somebody do it one time. So now I've remembered that that's what this looks like when we have a rectangle inside another rectangle. You label like. Okay? All right, now it's time to read the problem again. A square garden has a walkway 3 feet wide around its outer edge. If the area of the entire garden, including the walkway, so this big square has an area of 18,000 square feet. Okay, so let's look at the picture again. We need to think about the dimensions of the big square, right? So we have to think about what we don't know. We don't know anything about the small square. So I'm going to let the length and the width of the small square be x. So x is the length of small garden, just that garden, and that's in feet. Okay, so now I can write what the length of the big square is. So it's x plus 3 feet plus 3 feet. On each side you've got 3, so that's x plus 6. And then the length of the width would be the same, x plus 6. So now I know length and width of big square, which is big garden, and I know the exact amount. So area equals length times width. And I have this relationship, this equation. So I can substitute 18,000 in, and then length is x plus 6, and the width is x plus 6. So I'm just going to square that. So now we have the equation. Now we need to solve for x. Now, since there's only one x, I'm not going to multiply this out and use the quadratic formula. I can get rid of the square by square rooting. And so the square root of 18,000 is a decimal, 134.16 equals x plus 6. Now, it really should be plus or minus, but because x I know is positive, I'm not going to do that. And then I'm going to subtract 6. And so x is equal to 128.16 feet. All right, the dimensions of the planted area. Remember, we let x equal the length and width of the planted area. So the planted area is 128.16 feet by 128.16 feet. Those are the dimensions of the planted area. Okay, so now we're going to look again at linear models. So this is actually like the first one we did, miles versus cost. So just again, a linear function is y equals mx plus b, and the number in front of x is the slope. And on a graph, that's rise over run, or up the y unit and over an x unit. And b is the y-intercept, so the y-intercept 0b right here. Okay, so when you're reading word problems, this number m in the front of the x is going to be the rate of change. You're going to go up some amount for every 1x you go over. And b is 0b, right? So it's going to be the initial value when x is 0, right? So you can look for those things. For example, look at this one. It says water is being pumped into a swimming pool at a rate of 5 gallons per minute. So there you go. There's a rate. Initially, the pool contains 200 gallons of water. So what's that? That's the point initially. That's 0.0200, but let me explain further why, because I'm going to define my variables. I'm going to keep reading. Find the linear function v, so they're telling me to use v that models the volume of water in the pool at any time t. Okay, if the pool, now I'm going to stop reading because that you answer after you get the model. So our model is this volume, this linear function v that models the volume of water in the pool at any time t. We know that's function notation. If we know the time, the input is time, then we'll know the volume, right? So I'm going to write my Math English Dictionary. T is time, and what would be the units? Well, we're given some units here, 5 gallons per minute. So that would be minutes. And then volume, V of T, is going to be gallons. Now you might be thinking, where's the feet, the feet cubed usually we have with volume, but gallons is a unit that is understood to be in 3D. Okay, so if I know the time in minutes, I'll know the amount of gallons. All right, so I know it's a linear function, and so I know the rate, it's changing every time 1 minute passes, it's increasing by 5 gallons. So that is my slope. That goes in front of the t, 5t. And now I can explain further what's happening. Initially, the pool contains 200 gallons of water. So this is the ordered pair. If 0 minutes have passed, there are 200 gallons in the pool because that's what it started with. So that's our y-intercept. So there is our linear relationship. If I know t, then I'll know volume. So now that I have this relationship written out, I can now answer the question, if the pool has a capacity of 600 gallons, how long does it take to fill the pool? Well, we're looking for t here. And I'm giving you V. So this is an output-input question. So I'm going to have to put 600 in place of V and solve for T. So if I subtract 600 minus 200, I get 400. And 400 equals 5T. So if we divide by 5, we get T equals 80. Okay, so 80 what? Well, we wrote it down, 80 minutes. Every word problem, the answer must have units with it. Okay, so the last one we're going to do together is another linear one, but it's a little harder because we are not just flat out given the m, the slope, and the y-intercept. Okay, so it says the monthly cost of driving a car depends on the number of miles driven. Well, I'm going to stop right there and write the Math English Dictionary down. M is my independent variable, miles driven, and it says the cost, it depends on that. So it's just telling you that your independent variable is miles driven, and your dependent variable is your cost in dollars. So we write down that Math English Dictionary. What that means is if I know miles driven, I'll know the cost. All right, now it says in 1 month, the cost was $380 for driving 480 miles. And in the next month, the cost was $460 for driving 800 miles. All right, assume there's a linear relationship between the monthly cost, C, of driving the car, and the distance x driven. Okay, so it wants me to use x. I'm going to change that. Okay. Now, you're not given a slope and a y-intercept. As I said, what are you given? Well, you're given a relationship here. So that's an ordered pair. But the reason it's so important to write this down and to think about it is because you have to get the numbers in the right order. That's why they call them ordered pairs. So C of x means that you're going to have the x first and then the C. So my ordered pair would not be 380, 480. It would be if we drive 480 miles, then the cost is $380. And then the next order pair would be if we drive 800 miles, then the cost would be $460. So getting this order right is really important. That's why the Math English Dictionary is important. Okay, now it says find a linear function. So now I'm going to go through how do I find a linear function when I'm given two ordered pairs? Well, just like before, you need m and b. So y equals mx plus b. Well, you might remember there's a formula for finding the slope when you're given 2 points. It is y2 minus y1 over x2 minus x1. And something I noticed in WebAssign, just really quickly, is on a lot of these problems, it's going to ask you for net change. So this is how you find the slope. The net change is just y2 minus y1. Okay, so net change is y2 minus y1. The slope is y2 minus y1 over x2 minus x1. All right, we need the slope. So y2 would be 460 minus y1, which would be 380 over 800 minus 480. All right, now I'm going to put this in the calculator. 460 minus 380 over 800 minus 480. And that's 1/4 or 0.25. Now, I like to always make my slope an over 1. So I don't really like 1/4 with word problems. I'd rather have 0.25. Why? Well, what are the units on this slope? The units on slope are always what you see here, y units per x unit. And I want that x unit to be 1. So what this means is the y unit is dollars and the x unit is miles. So if we were going to interpret this, it would be, it's going to cost me 25 cents per mile. That's the rate of change there. Okay, but back to writing the equation. All right, so now we know m is 0.25. So I'm going to write y equals 0.25x plus b. So I need to find b. What you can do is just pick either one of these points because that's x and that's y. All right, so we'll put the variables right back in a minute. But what you're going to do is you can use this m, 0.25, and then use 480 for x and 380 for y to solve for b. So I'm going to put that in there and use just algebra. So I'm going to multiply first. So 0.25 times 480 is 120, and then you have your plus b. Well, now you can just subtract 380 minus 120 and get b equals 260. All right, so now we have our slope and we have our y-intercept, and we'll use the right variable. So our function is c of x equals 0.25x plus 260. So that's how you write a linear equation given two ordered pairs. You find the slope first, then you pick a point, plug it in to y equals mx plus b to find b, and then you have your equation. All right, now I've kind of been explaining this, so I think you should stop the video and try to answer all these questions and come back and check and see if you understood what these things mean and how to find those answers. Okay, how did you do? At what rate does the cost increase for every additional mile driven? That is your slope. That's 25 cents per mile. What is the initial cost? See, if I were to put 0 in for x, c of 0 to find the y-intercept, or x is 0 miles, you get c of 0 equals 260. So that means that even if I drive 0 miles, it's still going to cost me $260. So that's the initial cost. All right, if the car was driven 730 miles in a month, what would be the monthly cost? So that's our x. So this is an input-output question, so you just needed to put 730 in and get $442.50. So you have a unit on your answer. And then the last one, if the cost was $385 1 month, how many miles? So this time we're looking for our input. This is an output-input question. So you needed to write 385. That's what the cost is. It equals 0.25x plus 260. Should have gotten x equals 500. And then do you have the unit miles? All right, hope you did well on that one. That's the end of this lesson.